Assalamu alaikum. How are you, students? Again, Faisal Omar with chemistry class 10th, and today we are going to study the discovery of neutron and subatomic and other subatomic particles, like what kind of properties do they have. So let's start our lessons. As you remember that in our previous lessons we have studied about the Dalton and Thomson, and then we studied about Rutherford and a brief introduction of Bohr's atomic model. And students, electron and proton is discovered until now, and right now we are going to study about the discovery of neutron. Okay, students, you know that various experiments showed that nucleus had twice the mass of the number of proton, but no one knew that what is the origin of this additional mass. There was a question. Then some scientists had some experiments. They were trying to find out this additional mass. For example, the mass of an atom was twice the mass of the protons. No one knew what is inside the nucleus, what else is inside the nucleus except proton. But there were some predictions, there were some sayings that there's something else which has no charge, but its mass is equal to the mass of proton. But no one was able to prove it with the help of experiment. Who did prove with the help of experiment? Do you guys remember? Yes, none other than James Chadwick. Okay, in 1932, James Chadwick was a scientist who discovered neutron. This was the third subatomic particle. The first one was electron, then proton, and now neutron. This was the third subatomic particle. Exactly. How did he find the neutron? With the help of experiment. He bombarded a thin sheet of beryllium with the help of alpha particle, and he saw that there is some kind of electrically neutral particle was being emitted, which has a mass equal to the mass of proton. This was the equation of the reaction. What happened actually? As I told you before in our previous lessons, alpha particle is actually the nucleus of helium. So you can see over here, when nucleus of helium reacts with beryllium, which was a thin foil of beryllium, what happened? It turned to carbon-12 and one neutron was emitted. This reaction is actually a nuclear reaction. Okay? It is not a chemical reaction, it's a kind of nuclear reaction. When the nucleus of helium reacted with the nucleus of beryllium, carbon-12 came into being, and one neutrally charged particle which had an equal mass like a proton was being emitted. Yes, Chadwick called this particle neutron. So this was the third subatomic particle which had no charge, and its mass was equal to the mass of, or near to the mass of, proton. So overall, the three subatomic particles, the three most important subatomic particles, were discovered until 1932. So let's have a look what kind of properties does these three subatomic particles have. Electron, proton, and neutron. We know that electron has a negative charge and its mass is very small, and we have learned what was the charge and what was the mass in our first lesson. And protons and neutrons are called nucleons. Why they are called nucleons? Because they are present inside the nucleus of the atom. Let's have a look to a table in which we can show the symbol, the charge, and the masses of these three subatomic particles. Okay, over here you can see the first one is proton. What's the symbol of proton? The symbol of proton is P, or P plus, because why plus, why positive? Because it has a positive charge. What is the charge of a proton? +1. What's the relative mass? 1 AMU. We will study relative mass maybe in our next lessons. Actual mass is 1.67 times 10 to the power of minus 27 kilogram. This is the actual mass of one proton. Okay, let's come to the neutron. Neutron is neutral, so its charge is 0, and again the relative mass of the neutron is 1, and the actual mass is near or same like proton, 1.67 times 10 to the power of minus 27. When it comes to the electron, electron symbol is E with a minus or negative symbol, and the charge is -1, and this mass is 1 by 1840 times of proton and neutron, and its actual mass is 9.11 times 10 to the power of minus 31. Yes, exactly. So these are the properties of these subatomic particles. Okay, when these particles were discovered, scientists come to know what are the atomic number and what are the mass number. Let's study what is the atomic number and what's the mass number, which were discovered after the discovery of these subatomic particles. Okay, so atomic number represents the total number of protons in an atom. If someone asks you what's the atomic number of sodium, you can say that it's 11, which means there are 11 protons inside the nucleus of the sodium. And when it comes to mass number is the sum of the total number of sum of the total number of protons and neutrons. Yes, exactly. Let's have a look at an example. Over here you can see that this is the atom of helium, as we have discussed a lot about the helium and alpha particles. So I brought an example of helium. This is the helium. It is a symbol of helium. This is what the upper the superscript part is the mass number, which is the sum of total number of neutrons and protons, and over here in the subscript is the number of protons, so it's called atomic number, and this one is called mass number. Guys, please remember that number of protons or electrons are equal in a neutral atom. Let's work upon an example. If sodium atom has 11 protons, which means that each proton has +1 charge, so overall positive charge will be 11 plus. So when it comes to the electrons, there are 11 electrons orbiting in the energy levels of the sodium. So each electron has a -1 charge, so overall charge will be -11. If we add both charges, +11 and -11, what will remain? The remaining part, the answer is 0. So if sodium atom has 11 proton and 11 electron in it, in this case the overall charge of the atom is 0, which means is a neutral atom. Okay, students, let's ask something else from you. Do you know what's isotope? Do you know the discovery of neutron led us to know about isotopes? Before the discovery of neutron, no one knew about the isotope. So these are related to each other. So let's learn what's an isotope. The atoms of same elements which have same number of protons but different number of neutrons is called isotope. Let's work upon an example. Over here you can have a look at 3 isotopes of hydrogen. The first one is called protium. In this isotope there is only 1 proton inside the nucleus and 1 electron is orbiting the nucleus. And the next one is the other isotope of hydrogen. In this one there's 1 proton and 1 neutron. So the overall mass number of this deuterium is 2 and atomic number is still 1. Let's come to the third one. This is the third isotope of hydrogen. Its name is tritium. There is 1 proton and 2 neutrons inside the nucleus and only 1 electron revolving or orbiting the nucleus. So the atomic mass, the mass number of this one is 3 and atomic number is 1. Why atomic number is 1? Because all of them have same number of proton. And the atomic number specifies the type of element. If it's 1, it means that always it has hydrogen. Okay, let's have a look how can we write the atomic mass of an isotope of an element. There are 2 ways, students. The first one is put the mass number as a superscript before the symbol of the element. You can look over here. Helium-4 is the isotope of helium, carbon-14 is the isotope of carbon, and uranium-235 is the isotope of uranium. So when what's the next type? What's the next technique? Then we can write the isotope is just write the full name of the element, then give a dash, and then write the mass number, like helium-4, like carbon-14, like uranium-235. Yes, very easy. Okay, students, for today I think it's enough, and next day we will have another lesson. If you have any question, any suggestion, please write in the comment section below, and please be safe. Thank you.